So just going over the assignment for chapter 7. In a study of length of time it takes students to travel to TAFE in a country town, a researcher collects data on 22 students. The data in the table gives the distance that the students travel in kilometers and the time it takes in minutes. You got a set of data here. First question is to use your calculator to construct a scatter plot on time taken against distance traveled. In this investigation, distance traveled is the explanatory variable. So explanatory variable is your y variable. It's the one that goes on the vertical axis. So hopefully you remember that to plot a scatter plot you do go to, well, you need to enter the data into distance spreadsheets first. Let's go D for distance traveled, T for time taken. If you've got more than 1.5 tabs, then I'll recommend that you push the cross button and delete it all. This shouldn't be hard. This is just entering data, so I'm going to cheat. Alright, once you've entered the data in, which you can do in your own time and watch this later, distance traveled is the explanatory variable, so the D is your y-axis. Now to bring up your scatter plot, push the on button, go to data and statistics. T, which is time taken, goes on the x-axis, and then D is your y-axis, and there is your scatter plot on the CAS calculator. Okay, so from there you just probably need to take a photo of that and upload it to Compass or upload it to the work as well. Most likely we will require you to do one on your CAS calculator and then do one by hand. Now doing a scatter plot by hand is, don't just copy straight off here. Okay, what you are meant to do is look at the time taken, okay, or you can use the CAS calculator to help you. Look at the x-axis, so the lowest one is 0 and it goes all the way to 90. So what you need to do on paper is, this is going to be annoying, draw a straight line for your x-axis, draw one vertical line on your y-axis. You need to label this one distance. Oh, writing with a mouse is so hard. And then this one time. Okay. Then you need to label those axes as even intervals. Okay, so it'll be 10, 20, 30, 40, 50, 60, 70, 80, 80, 90. And then your distances is up to you. This one's got intervals of 5 because it goes up to around 50, maybe 60 will be a good idea. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Make sure your intervals are spaced as evenly as you can. As you can see here, I'm doing it on the mouse. It's very, very annoying. Doesn't quite help. Now, so this one is going to be 0. Now you should know how to plot points on a scatter plot. So the first point is 18 and 8. Okay, because X is on here. So 18, if I'm going 10, 20, this is 10, 20, 30, etc. The first point, which is 18, 8, so you go along to 18 and then you go up to 8. I think I use 5, 10. So the first dot goes here. Okay, then you go to the next dot, which is 38. So 10, 20, 38. So you put a dot there. So that's how you do a scatter plot by hand. Please make sure you use a ruler when you're doing the time axis and the distance axis, and please make sure you space these out properly. Then you just need to go along and do the rest of the dots for a scatter plot. So we will make you do it by hand and on the CAS calculator. Please make sure you do it properly. Now, one thing I need to make very, very clear. Very, 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 very clear. Because some of my U12 still do it when I tell them not to do it. And that annoys me the most, when I tell you not to do something and then you end up doing it. Alright. Am I still right? No. Okay. What I don't want you to do is, there seems to be a double line here. Yes? Okay, there's 2 lines. Do not draw the 2 lines. Okay, now I can't write very well with my mouse, so I'm going to circle it and go do not, do not. there is only one line, and that line always happens at the 0 most of the time. Okay, see how I put 0 and then I drew a line. Okay, there is no second line here. You do not draw this line. This line is the edge of the screen. Okay, so you only draw the vertical line starting at 0. Okay, if it's starting at 0. Do not do this. Okay, and some of the year 11s, maybe not you, will do it because they're like, oh, just copy off the graph. Copy off the CAS. Do not draw that green line. Okay, my vertical line is only one vertical line. Alright, use the scatter plot to describe the association between the variables in terms of strength, direction, and form. So strength, you've got strong, moderate, and weak. So you need to pick one. Weak. The answer to this one is most likely, well, it's not in a straight line, but it's not like a ball, so I'll go with moderate, which will be the answer. Direction is pretty straightforward. Direction, you're picking from positive or negative. Positive or negative. And in this case, it's definitely positive. And in terms of the form, you've got linear or non-linear. And this one is, I would say, linear. It's pretty straight. It doesn't really curve. If I was to draw a straight line passing through most of it, it will probably be, something like this. That's not straight. I'm just going to use this. Probably be something like that. Okay. I know it kind of drops off here, but it doesn't curve. You see how even though it does seem to curve down here, it curves up there as well. So overall, it's pretty much a straight line. It does need to have a very distinct curve. So when I say distinct, it must only do that. See, that would be a curve, but there's too many dots up there, so it doesn't count as a curve. So this one would be linear. Alright, determine the correlation coefficient R, and then write this to 3 significant figures. So the R value is calculated from the table. So you go back to this table here, you push menu, statistics, StatCalc, linear A plus BX, which is already should be in your notes. If it's not in your notes, I don't know what you've been doing, so you need to re-watch every single video I've done and make notes based on those. A plus BX, your X list is T, so as you can see here T, and your Y list is D, and then here K, and then your R value is down here. Now, sometimes in the table it doesn't show a lot of decimal places. Okay? If it doesn't show a lot of decimal places, you can read the whole thing here. So, the answer is 0.771932. I'm just putting a lot of numbers there. In terms of 3 significant figures, this was done in term 1. Okay, you do need to know this, significant figures. There is another worksheet on it, so you can practice if you need. But significant figures are all numbers greater than 0. There's a few other criteria where 0 is a significant figure, but that is also in your notes. So the 0 doesn't count, the 7 counts, 7 counts, and the 1 counts. So there's your 3 significant figures, except that the 1 needs to be rounded up to a 2 because of this 9. Okay, we still do basic normal rounding in terms of significant figures, but the answer is 0.772, which would be your 3 significant figures, and the 3 significant figures are the 772 there. If there's any questions, please type or let me know. Alright. Part D says use the least squares method to find the equation of, okay, so there's a lot of information, and as you get, when you do further maths next year, the question will have a lot of information, and a lot of it is just filler. It doesn't really, it's not important, especially if you're finding it trouble to answer questions because you don't know what you're doing. That, well, one, that just shows me you haven't done enough questions. But two, you need to look for the key information. So in this case, this question says find the equation for the line. Okay, everything else to me is filler. Okay, I don't need to do all that. Most importantly, find the equation of the line first, and then write the equation in terms of the variables involved, and then 3 significant figures. Okay. So we need to find the equation. The equation is here. It's already given to us. You should all know that the equation is y equals to mx, well, in this case, sorry, a plus bx. So you just copy that. A is that number there, which is 5.67649. Okay, as you can see, that's down here. It's always good to write more decimal places to start, and then just cut it later on. So 0.471657 x. So that's the first part, which is great. However, you need to write the equation in terms of the variables. Okay, second important part. So our y was, what was our y? Our y was distance traveled. So you actually need to rewrite this equation using distance traveled equals to 5.67649 plus 0.471657 times time taken. Okay, that's what it means by in terms of the variables. You cannot leave it with the y and the x if we give you what the variables represent. So that's very important. Alright. However, we need to finish it up with the 3 significant figures. So 3 significant figures, all numbers that are bigger than 0 are significant. So that will be the 5, that's 1, 6, that's 2, and the 7, that's 3. On this one, the 0 doesn't count, so it's 4, 7, and the 1. Oops. However, we need to do the rounding. So that means this 7, so we don't need those numbers. Okay, they're the 3 that we want. However, this 7 goes up to an 8 because of this 6. Cool. And this 1 goes up to a 2 because of this 6 here. Okay, those 2 numbers there, round it up. And that's your final answer there. Okay, moving on. Part E, which is the last one here. Use the equation of this line to predict the time taken for a student who lives 30 kilometers from TAFE. So this is what we did in term 1, where we just used the formula 72 multiplied by time. We are looking for the time. So we're going to change the distance to 30, and we just need to use the solve function. Times t, comma t, equals 2. Since I'm already in a table and this one is there, I'm just going to use the scratch pad. So solve that, and time is 51.525. It says the nearest minute, so t equals to 52 minutes. And then the question is asking if it's interpolating or extrapolating. The t of 52 minutes is actually within the data set. So what I mean by within the data set, we just look at the last dot point. Make it So the last or the first stop point is here, around there. I forgot what number it is. Maybe it's 8. Okay, and the last stop point is at around 90. Okay, now everything inside of it is called extrapolation. Extrapolate. No, sorry. My English. Everything inside the two lines is interpolating, and everything outside, so on the left of this line and on the right of this line, is called extrapolating. So t is 52 minutes, and then this prediction would be interpolating. Okay. Now, if you're doing interpolating, then the result is reliable. If you're doing extrapolating, so if it was extrapolating, then the result is unreliable. Okay, because we're using our equation to estimate something that's outside our data points, and that therefore will be unreliable. Whereas if we're predicting within our data set, then it will be more reliable. I know the question doesn't say whether it's reliable or not, but you may get one in the SAC, so you better know how to answer those questions. And this same question comes on the Year 12 exam pretty much every year, so it'll be a good habit to see those now. That's about it. Here's the answers. I think I got them right. 7.98. Huh. I didn't get it right. I got the second one wrong. No one spoke up. Alright, let's have a look. What did I do wrong? 7.98 and 1.26. Cool, that's a big difference. Let's see, did I get the 772? I got the 772. I see. I didn't read the question carefully enough. Okay, so when we did this part, so part A, part B, part C, yep, A, B, C, the question says distance traveled is the explanatory variable. Okay, so therefore the distance traveled is our y value, which I've kept there, which is fine. However, when we get to part D, find the equation which will enable time taken to be predicted from the distance traveled. Now this sentence is very important, and as per usual I should have read. We rarely do this to you, okay, but as you can see it can be done. We've decided that we need to make an equation where time can be predicted or calculated from distance traveled. In other words, time is now the y variable. So this is now the y variable, and this is now the x variable. Okay, so that's a good lesson in terms of make sure you read the question. So if we were to do that, then we need to do this again. The steps are still the same. You still do din reg a plus bx, but I'll just double check and make sure we get the right answers. So D is my x and t is my time now. And there we go, there's the numbers. So I'll leave that there because I feel like it. And I'll do the right answer in red. So it'll be time taken is equal to 7.98, which is the 3 sig figs, plus 1.26 times distance traveled. And then in here, because the formulas change, time taken is equal to 7.98 plus 1.26 times 30. It's a bit easier now. You don't need to use solve, which is 45.780. So that's the time. And we need to round to the nearest minute, so that'll be 46 minutes. 46 minutes is still interpolating because there it is, 46 minutes. Yep, right, everything else is right. I'll save this and I'll upload it as well as the video. Please rewatch it and please go over your revision. Do we have class tomorrow? Nope, we don't have class tomorrow. So your next period is your SAC. If you have any questions, please shoot me a Teams message and I'll go through things with you. Otherwise, the rest of the time is yours. Make sure you've done the chapter review. Make sure you go through this assignment as well as the chapter test. Otherwise, good luck. Once again, if you need any help, please let me know. Thank you.